Dear students, today we will start with the phase rule. There are two types of reactions are there. The first is the reversible reaction and second is the irreversible reaction. The irreversible reaction, we have one example. Zn when treated with H2SO4, it gives the ZnSO4 and H2 gas will leave out. This reaction is a irreversible reaction. Then the second is the reversible reactions. Again, in a reversible reaction, there are two types reactions present. The first is homogeneous reversible reaction and second one is the heterogeneous reversible reaction. For homogeneous, we have the example N2 plus thrice H2 gives our NH3. Twice NH3 we obtain. This two arrow represent there is a equilibrium is there. Your nitrogen is in the gaseous form, hydrogen is in the gaseous form, also ammonia is the gaseous form. This is homogeneous reversible reaction. Then some examples for heterogeneous reversible reaction. CO3 is decomposes, it gives the CaO plus CO2. CO2 is in the gas form, CO is a solid, and calcium carbonate is also solid form. Okay, this reaction is a heterogeneous reversible reaction because in this reaction one is the solid, other product will get solid, and one is the gas. There is a solid and one component is the gas. Therefore, this is a heterogeneous reaction. In this reaction, all the reactant and products are in same phase, that is in a gaseous phase. This is your homogeneous reversible reaction. For homogeneous reaction, there is a mass law we can use for the explaining this homogeneous reaction. But when you consider the heterogeneous reaction, you have to use the phase rule, and that phase rule was given by Willard Gibbs. That is one of the greatest scientists. And these heterogeneous reactions, equilibriums, we can study under the phase rule. Let's start the phase rule. Some important terms which will useful for studying the phase rule. The first is your system. Suppose we have a system is there is a jar is there, and in the jar there is a water, some ice is there, and vapors is also there. The substances are a substance or number of substances which is isolated from other substances. This is called as the system. This is a kind of system in which there is a vapor H2 is also there, and also ice is there, and water is also there. You found that the ice is the separated from our liquid, and vapor is also separated from these two phases. Distinct separable, your phases are should be the distinct and separable. Now, one thing is important when you consider these things. The phases is the important things for the studying of phase rule. Okay, we have already defined the your system. System is a substances. A substance or number of substances. Number of substances which is isolated by any means from other substances. This is a definition. This is a system where your ice is the separated from your water, and water is also separated from the vapor and your solid form. Now we have to study the phases. The phases are the distinct separable substances and which can be easily separable by mechanical ways. Suppose in this case, this is a system which contains there is ice is there, water, and our water vapor is there. Therefore, by using hand picking means we directly take this ice from outside. This is by hand picking you can remove the ice. Okay, then if the other type of system is there, in this system you have oil and there is a water is there. Okay, oil and water. There is distinct separable layer is there. Okay, therefore you can remove your oil from when it mixes with the water by using the simple separating funnel. You can remove the down this below layer and upper layer. Okay, by simple filter by using this separating funnel, you can remove the lower layer and you can easily separate oil and water. Okay. Therefore, phases are the distinct separable things or substances which can easily remove by using mechanical ways. During this process or during removing of these substances, there should be not change in temperature and pressures will be there unless for example when you use the distillation there is a change in temperature is there. Suppose we have we heated this system, there is a temperature is changed, water is no doubt water will be removed, but temperature is changed, pressure is changed. Therefore we have to avoid these things. Vacuum distillation or distillation, fractional distillation, such methods we not use for the separation of phases. Okay, therefore we define as our phases. Phases is a distinct separable substances from a system which is separate from other system by a definite bond. This is called as a phase. For deciding phases, we have some rules are there. By using these rules, we can find out the phases present in systems. These rules are rules for identification of phases. First rule is every solid is considered as a phase. Okay, phases will be solid, liquid or gases. When in your system, if more than one solids is there, then each solids you consider as a phase. For example, if you have the example, calcium carbonate decomposes into calcium oxide and CO2. It is gas form, solid and solid. In this case, we have two solids, first solid and second solid. Therefore, we consider this solid as a separate phase, first phase and then second phase. You remember that. And there is also gas is the third phase. If different substances are there, each substance is considered as a phase. Second is for a liquid. Second rules is for considering liquid. If liquids are miscible means when they mix, they not is separated by a layer, they are totally mixed. For example, when you add alcohol into water, they are not, you not looks it as a, there is a separate layer, they totally mix, no discrimination you found there. You cannot remove by the filtration alcohol from water, but where you can remove by heating. But in these cases, we not use the heating, or by there is a change in pressure, there is temperature. Such methods is not applicable for this when you use the phase rules. Therefore, this is a homogeneous. Totally, this water and alcohol mix, it is a homogeneous. Therefore, when liquids are miscible, it is considered as a single phase. Okay, first is for the liquids are miscible, and second thing is for when liquids are immiscible. For example, when you add the oil in the water, then there is a two distinct layer you found there. Okay, this is your oil and this is water. Two separate distinct layer you found there. And therefore, when liquids are immiscible, then each liquid considered as a phase. For example, for this case, you consider oil is one of the liquid phase and second phase will be water. This is the second method to find out the which phases is there. Third is the for gases. Okay, for firstly we see solid, then second we see the for liquid, and third for gases. For gases, if number of gases is there, they are not distinct, we cannot separate. In air there are the nitrogen, hydrogen, oxygen, CO2, vapors. Number of gases is present in air, we could not separate them. They forms the homogeneous mixture. Therefore, when there is a homogeneity is there, homogeneous mixture is there, then it is considered as a single phase. Therefore, number of gases if there, you can consider gases is a single phase. Remember that. Fourth is fourth rule is considered as when there is a solution. For example, when NaCl is dissolved in water, it totally dissolves and it makes the homogeneous solution. We could not identify there is a NaCl because NaCl totally dissolved in this water. It forms the homogeneous solution. Therefore, such kind of things, if there is present, then it is a single phase. For the solution, you consider as a single phase. The constituents and phases are the two different things. In this case, when you NaCl dissolve in water, there are two constituents. Constituents, NaCl is one constituent, water is the other constituents. In this case, there are the two constituents. Oil is also constituent, water is also constituents. In this case, this is a different things Different chemical formula things is the constituents. Remember that. Now, by using all these rules, we can predict how many phases are present there and which are they. We can predict by using this phase rule. Another thing is, important thing is there, if there is a hydrate compound is there, for example CuSO4, there is a 7H2O, one of these present, and CuSO4 5H2O is present. Okay, this mixture is there, if suppose, and third is the CuSO4, our 3H2O is present. Okay, this if there is a such kind of hydrate mixture is there. Okay, H2O means if there is H2, it is hydrate. H2 is called as the hydrate. Compound is associated with H2O. Therefore, each hydrate considered as a single constituents. Okay, and each hydrate is considered as it is solid one, it is solid one, and it is solid one. Therefore, each hydrate is considered as a single phase. Remember that. Now, we will discuss some examples related to the phases, and we have to try to find out its phases. First examples is the NH4 Cl. When it decomposes, it gives NH3, that is ammonia, plus our HCl gas. All is the HCl is into gas form, ammonia is gas form, this is into solid form. Find out its phases. How many phases is present in this particular equilibrium? We have used the rules we studied. The first is each solid considered as a phase. Then if there are gases, number of gases is there, all the gases considered as a one phase. Okay, if suppose you consider NH3 one phase, then HCl is the second phase. This is not correct one. All the gases come together forms a phase. For this case, your gas, NH3 gas and HCl gas is form a gas, and it forms a two phases system. Remember that. Now we have one of the example is there, CuSO4 solid plus our 5H2, it gives CuSO4 dot 5H2. It is solid, it is liquid, and it is also solid one. According to our rule, each solid considered as a single different phase. For this is a one phase. For liquid you consider other phase. For solid there is other. Therefore, in this case there are three phases present. We have another example. There is a PCl5. It gives the PCl3 plus Cl2. If suppose it is solid one, it is also solid one, it is gas one. In this case, your first solid, second solid is a 1, 2, and gas is the third one. Therefore, this is a system which consider as the three phases. Now we have NaCl. When you dissolve in water, then it forms a solution. NaCl plus water, it forms a solution. Therefore, it mixes together and forms a homogeneous solution. There is no distinction. Phases are the distinct things and we can separate through mechanical ways. Okay, by heating you can separate, but this method we not use. Is directly visible. Remember that phases are the visible. Visible means it can be separable. Phases are the separable by using mechanical ways. In case of when there is ice, water is there, you can easily hand picking method, or if oil, water is there, by simple filtration method you can remove these phases. In these cases you found that NaCl is not visible in this liquid, therefore it forms the homogeneous solution. NaCl is not directly you can remove from this jar, therefore this is this considered as a single phase. This is a single phase. Remember that. If suppose we have one of the example Hg, your liquid form plus H2O liquid plus CCl4 liquids, all are the liquids. In this case there are the liquid is first okay, it is not miscible, second, third and fourth is their vapor forms. Okay, this also forms the vapor, therefore in this case it is a 4 phases system. Okay, like that by using the rules we can predict how many phases are present in a systems. Okay, systems is nothing but a number of systems. Suppose in a test tube or in a jar, that particular jar, when you put the water is there, ice is there, vapors is there, it forms a number of the systems. In system there is one substance or more than one substance is present, but these substances are separable from each other, or these substances are isolated from each other. Suppose in oil, when you mix the water, you can clearly see oil is separate from the water and there are the two substances. Like that, in first method, in first example, we seen that there was the ice, water and the vapors. In this system there was only one substance was there, but phases was different. Therefore phases is we define as phases is distinct one. We can see the phases. See means the separate. It is possible of separation. Distinct phases is the things which are separable easily by mechanical ways. This is called as the phases, and the number of rules, 4 or 5 rules, 4 rules we seen for the find the phases in a systems. Now we will start with components. We are interested in what is meaning of components. We discuss the meaning of systems and we discuss the phases. Now very important concept is the component. Suppose we have the systems. Okay, already we discussed that system. The system is there is ice is there, okay, and water is there and there is vapors is there. Okay, such system is present at a particular temperature. The kind of system is present. Okay, in this system you can describe this system by using, okay, ice is also H2O, your liquid water is also H2O, your vapor water is also H2O. Therefore this system totally we can explain the composition of this system. We can explain by using the only one chemical basis. Therefore component for this system is one. Okay, we can define the components minimum molecular basis. Remember that minimum molecular basis, which describe the composition of system. This is called as the components. For understanding these things, we will consider some example. First example, it is a single component system. This is a single component system because this system is explained by using only one component. Okay, now we have one another example is there. If suppose you have the decomposition of ammonium chloride, NH4Cl is a solid, it gives ammonia plus HCl. Ammonia is in the gaseous form and HCl is also gaseous form, it is a solid form. Number of phases for this, for which solid is considered as a one phase, is gas considered as a, number of gases considered as the one phases. Okay, therefore total phases for these systems is 2. Phases and constituents are a different concept. In this case, first constituent, second constituent and third constituent. Each chemical species is a constituent, but each chemical species is not considered as a different phases. Okay, for this, if you gas is mixed together, it forms only one phases. Therefore, phases and constituents are a different concept. Remember that important thing. Now, when decomposes this, it gives the equimolar quantity of XNH3 and XHCl. Okay, this is forms of one phase. This system is a one phase, and this is the one phase. Okay, one phase system is described the one phase system. Okay, because X number of NH3 molecules gives the X number of NH3 and the X molar. This is equimolar quantity we obtained for this system. Okay, when pressures of NH3 and HCl are same, when pressure of NH3 and HCl is same, then these two quantities are equimolar. Therefore, how many number of components present in this system? We define the components. Components is a minimum number of chemical species which gives the composition of a system. In this case, when we have X is decomposed, definitely it forms the equimolar quantities of X, therefore it gives the X quantity and it gives the X quantities. If I said there is a X quantity is there and it deposited, X mole of NH3 is deposited, NH4Cl is deposited, it gives definitely the equimolar quantity of there, because there is a phases, same phase and same phase. This equimolar gives the same quantity. By using only one any component, you can get the composition of all the system. For example, if I said X is the NH4Cl, therefore you can easily say that the total is converted into a single phase, and in this case number of X is produces, number of XHCl is produces, X NH3 produces and XHCl produces. Any chemical species, if you describe, then it gives the all information about this system, all information or all composition of this system. Because when decomposes NH4Cl, it gives the equimolar quantity of HCl, and in this case pressure of NH3 and HCl are same. Therefore we can say that this system is a one component system. There is a one tricks for find out the component is equal to number of phases minus there is a relation, okay, individual relations of each substance is number of phases minus the number of relations, individual relations, separate relations. Separate relation means the how many equilibrium is there. Okay, roughly we can say that how many equilibrium is there. Therefore, in this case, we have two phases minus there is relation only one. These two substances are the related only one equilibrium, that is individually they are the only one relation is there. Therefore, 2 minus 1, this system is a one component system. Okay, this is the one of the tricks. Other tricks is there if in case at this side is there your only one phase is there and other side there is only one phase is there, and then you can consider it as a single component system. Remember, if it is a solid and the gases like that system is there, therefore you have to think on these things on this reaction. Therefore, if there is a such equilibrium is there and then only you can use this kind of formula, number of phases minus number of individual relations is there. Remember that. If a system which contains only one chemical basis, in these cases we not use this relation. For example, in H2O there is a ice is there equilibrium with H2O, liquid is equilibrium with H2O gas. In this case we not use this because there are number of three phases are there and relation is the also relation is the two relation is therefore 3, this is also used. In this case 1, 2, 3 phases is there, 3 minus there are the two relation, therefore it has the only one components. Like that way you can find by using this formula you can find the number of component is there. Okay, this system we can explain by using this rule. By using this rule, it is a one component. Suppose we added in this above system, suppose we added YMlHCl. When you add in the above system, there is XNH4Cl, it gives XNH3 equimolar XHCl, and we added the YHCl. Previously we said that it is a single component system because any chemical basis can give the composition of this reaction. Now you said there is a XNH4Cl, then okay, in this case pressure of HCl and NH4 is different, is the XY is there therefore such kind of relation if different pressure is there you consider. When XNH4 it gives the XNH3 but it not give the XHCl because we added the HCl or we added NH3. Okay, you can vice versa, you can add, when you add the NH3 system YNH3 add, or when you add the HCl YHCl add. Therefore only this quantity is not excellent total system. Therefore we also consider this YHCl or this HCl quantity, then and then we can gives the component for this system. Therefore for this system one chemical basis and second chemical basis gives the total composition of the system. Therefore this system is a two component system. Remember that when you add the additional thing. Now we have the other example is there. If suppose there is a system which is having CuSO4 pentahydrate, CuSO4 trihydrate, CuSO4 monohydrate, simple CuSO4, then CuSO4 solution plus ice plus water. If suppose these are the such type of system is there, and you have to find out number of components there. Firstly, how many phases is there? It is a solid one, it is a solid also, it is also solid. This CuSO4 that is there is no hydrate, there is no H2 means it is a unhydrated CuSO4. If there is no H2, it is unhydrated CuSO4. CuSO4 is solution which is liquid form, ice is the solid form, water is also liquid form. Okay, therefore phases are, each solid is considered the first phases. This is one phase, second phase, third phase, fourth phase. Liquid is the 5 phase. So this is also the your next phase, and water that is our this is a mix. Therefore water is solution is there. This mix, this is considered as a single. Okay, this okay, this is solid, not a, and water is a another. Okay, number of phases are there. 1, 2, 3, 4, 5, 6, 7 are the phases is present in this case. Now we have to find out the number of components for the this system. We have a we can draw a table first. There in this case is the phases and chemical formula and composition, chemical composition explaining the formula. First we have CuSO4 pentahydrate. Okay, the phase is the solid. CuSO4 pentahydrate, therefore it can describe as a CuSO4 plus H2O. Then second, it is also solid. CuSO4 thrice H2O, it is also explained CuSO4 plus H2O. Okay, 5 and 3 H2O. Again, third is our CuSO, solid one is there. Solid CuSO4 H2O is there. CuSO4 plus H2O. Then fourth one is the unhydrated solid. It is also solid unhydrated. CuSO4. It is only have the CuSO4 and number of H2 is the 0 H2O. Now the solution, liquid phase, solution of CuSO4 solution. Okay, it means the CuSO4 plus H2O because it makes the solution. Number of solution X, n number of solution. Now 6. The ice, that is solid one, ice is also the H2O. Its composition is H2O. Now 7 is the water. Water is the liquid. Okay, its phase is the liquid. It is a H2O. It is has the H2O. Okay, when you consider this system, how many components should have required to explain this composition of all the systems? In this case, you found first chemical formula. You found there is CuSO4, and other composition H2. In also CuSO4 H2O, CuSO4 H2O, CuSO4 H2O. In this case, 0 CuSO4. CuSO4 is also 0 in this case. Okay, CuSO4 H2 is required. CuSO4 H2 is required. CuSO4 H2 is required. H2O, CuSO4 H2O, CuSO4. Therefore, this system is explained by using only two chemical phases, CuSO4 and H2O. Other than there is no chemical phases is present. Number of phases is no doubt, number of phases is different. But how many component present? Component is a minimum amount of chemical basis, molecular basis or chemical basis which describe, which gives the total composition of the system. This is called as the component. For this, CuSO4 and only water is describe this system. Therefore, this system is a two-component system. Remember that. Now we have one system is there and very confusing system is there for find out the components. Calcium carbonate is decomposed into solid is decomposed into CaO plus CO2. In this case, gas phase, CO is the solid phase, this is solid phase. This is phase for this system is this is solid, this is plus solid, and this is the gas. Therefore, number of phases in these systems are 3 and number of constituents is also there 3 because this is one of the chemical pieces, second chemical pieces. Number of chemical pieces we consider constituents. Number of phases by using these 4 rules we can decide the phases in a system. Now you consider at this side is the solid and this side is the 2 phases are present, solid and the gases. Therefore, in this case, as like NH4Cl, it gives the NH3 and HCl, both are the gases. This is also solid, but the single phase is present as a product and single phase is present as the reactant. Such cases we not use like that. Equimolar concept is not useful because in this case only one component can describe for a system, but in this case we not use such rule because the phase for the reactant is the different. Therefore, we not use only one component this describe the system. In this case, you should require the 2 components. Then and then you can describe system because if you describe the solid solid describe, you get the answer the second solid. But what about the gases? If you consider the gases, the chemical pieces, what about the solid? How you define the solid? How you describe solid? Therefore, such cases is there, then different scenario is there, and it's confusing example how there is a 2 component presents. By using our one rule, there is a number of phases is the 1, 2, 3. Number of phases is there 3 minus number of individual relation is the 1. Therefore, 2 components by using our formula. This is a 2 component system. How it is 2 component system? Suppose we take these 2 first, then CaSO4 you can use like CaCO3 in X quantity, then 0 quantity of CO2. Okay, when you consider CO2, only CO2 and CO3, then when you have to describe the CO2, then it can be described as CaCO3 is 0 quantity and CO2 is in X quantity. If you describe CaO, then from CaCO3 you have to remove the CO2. You can give the answer of this. Okay, this is the first case. Then when you consider the CaCO3 and CO2, then CaCO3 gives the CaCO3 and 0 CO2 you require the because gas and solid. Then what about CaO? You can give CO2. Second is you go to CO2. Then 0 CO3. Okay, in this case this is 0. Then CO2 is there. When there is CO you can give the CaCO3 minus CO2. In this way you can okay for this you can explain the system. Two chemical phases by using, you can explain the other 2 chemical phases by using the only 2 chemical phases. Therefore, this system is a 2 component system. Remember that important thing. Like that way we also third we can use CaCO3. It gives the CaO plus CO2, then CaO, then CaO plus 0 CO2, and when you CO2, then you can use the CaO 0 and CO2 is there. Like that way, when you explain by using this 2 kind of things, you can explain the system. Okay, in this case we explain the system CaCO3 and the by using CO2. Okay, in this case also we use CO2. Okay, sorry, in this case we have to use the CO. Like the three only other two components by using we can describe this kind of system. Remember that, because why not we use this? Because if you not get this, you can simply directly use the rule, number of phases minus number of relation is there. You can directly predict the components. Okay, this is all about the important parts, basic parts we have studied in this lecture. Very important, system is important, your components is very important. Then in next lecture we will discuss the how to find out the freedom of a system. Thank you very much.